Hello, this is Christophe de Dinchin, and today I'm going to give you an update on DB48X. The latest release is version 0.4, which I released today, and it has two major features. One is matrix operations, and the second one is symbolic rewrites with a basic implementation of collect and expand. So we are going to see that in a moment. There is also a neat new features for entering alphabetic numbers. So, as usual, I'm starting with the stock DM42 firmware, which you can see here. This is the usual RPN calculator that you're familiar with. And I'm going to go to the setup menu, then system, enter system menu, reset to DMCP. And I'm going to first activate the USB disk in order to copy the PGM file and the QSPI.bn file to the calculator. Then I can eject the volume from my computer. And now I can load QSPI from FAT. So this is loading the QSPI.bn file, which contains one big half of the firmware, mostly the data. And then we are going to load the program itself. So like for previous releases, this QSPI.bn is compatible with the DM42 firmware, meaning that you can run your usual DM42 program with it, as we are going to do right now. So you see that I can still use the calculator the usual way, but I can also go to system again, reset to the MCP menu, and now load program. And I'm going to load the DB48X program. So it has grown a little bit since last time, which is expected, since there are many new features. After you have loaded the QSPI file, you can switch back and forth between 48 and 42 mode simply by loading the PGM file. So the first thing you might notice at the top of the screen is that there is now a display of date and time. So it's an option that you can select. The way to display that is with the setup menu in the status bar option, and I can select, for instance, to show seconds or not, or the order in which I'm selecting, I'm displaying date and time, the date separator, etc. I can also choose whether I want to display the battery voltage or not. So let me remove, for instance, the day of the week to have a little bit more room for that display. You can see that the battery icon has changed a little bit as well. So there you see a grayed out battery icon when it's on USB. And if I disconnect from the charger, it's going to shift to this icon indicating that it's on battery. So I'm going to stay on USB for now, simply in order to avoid using my battery too much. So this is an RPL system. When you enter numbers, you see that there are the separators showing up, and you have an infinite stack, and you perform your operations using the normal operations as you expect. If you want to perform an operation like computing the sign of this number, you simply hit sim. So this is relatively usual if you're a bit familiar with this kind of calculators, the HP48 series. This is going to feel relatively familiar, but with a number of nice enhancements we are going to see. So we have integer numbers, which can grow pretty big. So let me give you an example. I'm going to compute this to the power 200. Oops. And you see that this is a pretty large number that I can put on the stack in order to see all the digits. Sorry, I can put it on the editor. So because this is a command line, the RS key plays the role of a space key once you are on the command line. This, if held, repeats. And so I'm entering multiple numbers at once. This is exactly like on the HP48. If I'm not editing, then this plays the role of evaluating, and we're going to see that in a moment. So if I want to enter alphabetic characters, I can switch to alpha mode with Shift Alpha, and you see that the indicator ABC switches on here. And now if I type the 1 key, I'm going to get an X instead, because that's the key that is on the left. Oh, sorry, on the right of the 1 key. So I'm typing in alphabetic mode here. And this is very useful, for instance, to enter arbitrary commands. So for instance, the same sin operation that I was doing before, I can now do by typing SIN. And it's computing the sign of this symbol. So let me do that again on 3. And you see this is the same result as if I type the key. So I can enter arbitrary commands like this. And because alpha is used so much, there is another way to enter it, which is to hold the yellow key. And so if I hold the key for more than half a second, I enter alpha mode as well. Now, the difference between the two ways of doing it is that if I enter Shift Alpha, I can also switch to lowercase like this. And this is not possible by holding the key. Now, one thing that is new in this release is another way to enter alpha, which is to hold one of the arrow keys as well as a letter. So now this is called Transient Alpha because it goes away as soon as I leave the keys. So this is a very convenient way to quickly type alphabetic symbols. And you can see that the alpha symbol is there. As long as I release the key, it's gone. While I'm in alpha mode, I can enter digits by using Shift. And I can enter symbols, same thing, like this. So to execute a command typing its name, we saw that I can simply type SIN, but there is a shortcut. So let me enter alpha mode, and if I type S, and then the plus key here, what you see at the bottom is a catalog of all the functions that begin with S. And if I type I, then I have all the functions that begin with I. This includes my sign function here. And so this is another way to access a very large number of functions very easily. So again, you simply type on the plus key. You can also bring the catalog at any time with Shift Catalog. So this is consistent with the catalog option shown on the plus key. Now, one of the commands I'm going to use here is version. So I'm going to type, V-E, and you see version here. And this gives me the version of the software running here. So I'm going to use that to demonstrate how the multi-line editor works. Because we have only 2 arrow keys, unlike the HP48, which has 4, I had to make a choice. So what we have there is left and right movement when we use the up and down arrow. And if I want to have up and down movement, then I need to use Shift in order to do that. And as you can see, it repeats. I can also use double Shift to go to the beginning and double Shift to go to the end. So this double Shift is another way to recover some of the features that we don't have on the HP42 because we don't have as many keys as on the HP48, which is to mimic these two keys here. So the first Shift brings me the Shift function. The second Shift brings me the right Shift function. And we're going to see how this works in a moment for another number of things. Okay, now for all the functions, if you hold the key, you're going to see online help for this function. So I hold send until it brings the online help for send. And there is a new menu here that I can activate with the shortcut keys. So for instance, I can go to the home, the main topic overview of DB48X by hitting home. I can move pages up and down. And for instance, I can go to a new section in the help, which is acknowledgements and credits, which gives a number of information about this project and what made it possible. So the release information that you have also gives you, so if I go back there, you have a state of the project, you have a design overview. Now this help is built from the exact same files that you can find on GitHub as well. So in other words, you have the same help inside the calculator as you have on the project's website. I can also follow links, so simply by hitting on enter, and I can go back in the history of where I was with the back key here. Now, the help key is also mapped as the second Shift here. So if I want to have some help on whatever is on the stack here, I can do double Shift plus, and it's going to bring me help about the representation of decimal numbers in the calculators. If I put, for instance, let's say a matrix, and I do double Shift help, I'm going to have some help about vector and matrices. And if there is nothing on the stack, then you're going to go to the overview, the main help. I can also put a specific topic. So to enter a text, I can use double Shift alpha. And I'm going to use here something like, for instance, the scene function that we saw earlier. So I'm going to, whoops. I have to type quickly without breaking my rig. So I have this topic and I can do double Shift help, and it brings me the same topic as before. Now we have seen all these menus at the bottom. This is the simple case where there is a single row and I can go to the next. You see the little row there brings me to the next one, and if I shift, I get to the previous one. So there are multiple pages and I can go through the pages like this. So you got a good idea of the number of functions that are already implemented in the calculator. But you can have more than this. And the most useful menu is with Sigma plus, the A key, is the tool menu. If there is nothing on the stack, it simply brings me a top level menu here with the same help information and direct access to some menus. This is going to change. Which menus I can get there will change. Now, let's say I enter a real number and I use this. Now I get the menu for real numbers. if I type matrix and I hit this key, I get the matrix menu. And if I type, say, a complex number, let me go to another menu, let's say the modes menu, and now I hit this key and I get back to the complex menu. So this tool menu really brings me to the useful menu for whatever I have on the stack at the moment. So this is a new feature in 0.4 as well. And so you saw that when I have multiple entries, there is no need for a next key. The HP48 had a dedicated NXT key and previous. This is replaced with these arrows here. So again, because I don't have as many keys. Now, another thing that is neat is that I can return back to the previous menus. So there is a menu history, and you see I am going back into the menus that I visited earlier simply by hitting Shift and A. So this is the back menu feature. Now we saw the modes menu. The modes menu lets me change a number of settings in the calculator. So for instance, let's say that I enter the number 2.3. I can display it with 3 digits in fixed mode, or in scientific mode, or in engineering mode. So engineering mode is with powers of 3. So if I multiply by 10, you see that it shifts like this, and then it goes to the next power of 3. Another mode that is new to the DB48X compared to HP calculators is Sig Mode. And Sig Mode will not display the zeros, but it will limit the number of significant digits. So for instance, I can limit to 3 or 2 significant digits with 2 sig. And you see that now this displays like this. It's more, let me enter a number with more things. You see that it limits to 2 significant digits. But it doesn't have trailing zeros. So one particular application of this is to use 12 sig, which would give me more or less the same output as the HP48, even if the calculations internally are done with 34 digits. The systems menu that we saw with Shift Setup is relatively close to what you have on the DM42. It lets you, for instance, load. I could return to DM42 by simply loading this program. I'm not going to do that right now. What is really useful is that state menu here, where you can go back and forth between various calculator states, and you can, for instance, save the state as is currently. Let me save that to test, for instance, and I'm going to override that. And you see that an interesting bug here, that it doesn't cut the name. I have to fix that. Demos are very good for that because they let me find a number of interesting bugs. So this is the name of the current state that you see in the menu, in the header. Now you can save the current state very quickly by doing this, Shift off, and that saves the state. So now if I go back to, so let me, for instance, put that 3 items on the stack, like this. Shift, save. I hold it to see the help about it. Save state. Shift, help, save. And now if I wanted to return to some other state, let me go back to previously loaded state here, and you see that I have the state I had on the stack before. So that was my default state when I started initially. So one interesting menu is the vars menu or recall menu that I get with the recall key. So this is roughly equivalent to the vars menu, or var menu, sorry, on the HP48. These are the variables that I have loaded in my system at the moment. And you can see how when I shift, I go between 3 rows like this. So this gives me up to 18 functions in menus at the same time. For variables, the first one is to evaluate the program that is there, or whatever is the content of the variable. So for instance, this is the n-queens problem. And so you see I'm executing it like this. If I shift it, you see the little arrow on the right of the name n-queens. That means I'm going to recall the value of that variable, and that means I can edit it like this. So I can edit my program like this. And with 2 shifts, it means I will store it. So now I update it like this. So I can also store a variable with the store command. So let me do that by making a copy of this program. For instance, I'm going to take this program out. And if I use the XEQ key, that gives me the ticks that are very frequent on the HP48. So that's more or less the same thing as this key here, the tick. It's for equations or symbols. And so in that case, I'm going to call it PQR and hit the store key. And now if I recall this variable, I have the same content and I can evaluate the same value under a different name. Now I can also use these symbols to select a name. And for instance, I can use the memory menu. I have a purge function here. I'm going to purge this variable and it's gone. So let's enter a very simple program that adds 2 numbers. So the PGM key here inserts, so Shift RS, inserts the chevrons that separate programs in RPL. And I'm going to type 1 plus, and so this is going to write an RPL program that adds 1 to the stack. Now I hit execute. I call this, for instance, let me call that incur. And stow. And now if I do 2 incur, you see that it increments the variable every time. If I want to edit that program, let me do that quickly. Down key, let me replace that with a 2. Stow, and I've edited my program. So you see that this is pretty functional already. We already have a lot of the functionality for RPL calculators working well. So we saw that the RS key can be either space or the evaluate function. If I hold the help there, it's going to tell me that RS stands for evaluation. Run, stop, you evaluate. So let me recall that program there. Sorry. Let me recall that program here. Put a value above it. If I do RS, it's going to evaluate the program on the stack. So this is pretty quick. When we are editing, I mentioned that you can, if you hold RS, you don't get the help. Instead, you get spaces, and you can insert spaces like this. So let me run a slightly more sophisticated program. This one is myFact, and it's a short RPL program that computes a factorial. And I can run it either on the stack, like this. And I've computed a factorial of 100, which, as you can see, is a relatively large number. When you have large numbers like this, you might want to change the fonts used for displaying. So there is a menu in modes for that. You see fonts here. And I have a setting for the result, which is the first level of the stack, the rest of the stack, the editor, and the editor when there are multiple lines. So let me switch to a smaller font for the result. You can see that I can display more digits like this. Or I can use a bigger font if I had a bad eyesight. So let me return to the standard result and use a smaller font for the rest of the stack. And this is the result that I get. So you can customize it pretty nicely that way. You can also use various fonts from the DB48X. So I'll let you explore with these fonts if you want. Let me return to a more normal display for me. So one of the things that was important for me was base numbers, because I tend to work with this kind of binary, decimal, hexadecimal numbers. And so the basis number that you can, basis menu that you can access with Shift-4 base here gives me access to a number of features like this. So for instance, I can build an hexadecimal number, and you see the cursor changes to be there, which means that I can enter hexadecimal values easily like this. And this number displays with its base, which is base 16 here. And I can end it with, let's say, FF, like this, and I get the result. Now, when you work like this on these numbers, if you invert that, you see that it's doing the computation on 64 bits. But I can decide to change the word size. That's the word size here, word size 64. I can change it to 32. And now it's computing on 32 bits. Or I can use more exotic values like 24 or even, let's say, 17. Word size. And now it's computing on 17 bits. It can also compute on very large word sizes, for instance, 256. And if I do a not, now I have a pretty large number that I can explore. So this lets me do all the computations I want in any word size I want. Now, what if I want to work in other bases? Well, I can display that number in binary, in octal, in decimal, hexadecimal, but I can also use any arbitrary base, for instance, base 3. So this is the same number in base 3. Now let me enter FF in base 16 while I'm working in base 3. So I do 16, which is the base I want to go to, and then I'm going to type FF. And that gives me FF in base 3. If I switch back to hexadecimal, I got FF. So I can enter arbitrary bases and work in arbitrary bases. You see that there are some exotic operators as well, like NAND, NOR, implies, exclude, etc. So a lot of useful features for binary numbers. Now, we have seen symbols before, and that's, let me enter a variable X, enter a variable Y, and I can add them. So like the HP48, there is support for various operations in algebraic form. The tools menu in that case brings me these kind of features. So for instance, let's say I did this and I type +0. The equation is entered like this. If I hit simplify, it's going to remove that. And it's also transformed my power of 3 into using the built-in cubed function. If I do 1 over this, So this is the built-in functions shown with these upper with these superscript numbers like this. So if I evaluate that and there is no global with that name, nothing happens except for basic simplifications. So for instance, let's say I try to add 0 to this, nothing happens. If I multiply by 0, I get 0. So some basic simplifications like this can happen. They are controlled by one of the mode menus. Let me enter x plus y and try to evaluate that with a value in x. So now let me store, for instance, a times b, oops. And I'm going to store that in x. And if I evaluate that, now I have a times b plus a plus y. That's exactly like on the HP48. So let me purge x now. Make sure it's gone. So in terms of what you can do with algebraics, the most powerful tool we have at the moment is rewrite. So let me show you how that works. Let me enter an equation like a plus b, oops. You have to be fast when you use the transient mode, which is very convenient when you are not next to a camera. I want a lowercase. And I'm going to multiply that by itself. Now I can decide to apply a rewrite rule where I want to replace x plus y with, I'm going to swap the terms, for instance. No, I want y plus x. And I'm going to add times 1, which is not very useful, but let's do that. Now, remember, the tools menu brings me the useful operations for algebraics, in that case, rewrite. And so what this is going to do is to rewrite the a plus b term in there. Okay, that was... frankly, I did not think too much about the kind of rewrite that we would do, so it looped for a while. But you use, so let me try again with something more interesting. So, so we had x plus y sin, and let me replace that with, so a plus b replaced as, oops. Well, let me do that. I'm going to replace a plus b with tangent of a plus b to show that I can do arbitrary changes. But this is going to loop also because I have so just to avoid a loop. So I'm going to replace a plus b by a tangent in the expression and I do rewrite. And now you see that it replaced my x plus y with tangent of x minus y. So this is the basics for the implementation of collect and expand. So for instance, if I do x plus y multiplied by itself, and I do an expand, it expands all the terms there. Now this is an incomplete implementation because, as you see, it doesn't group the terms the way the HB48 does, and for the same reason collect is still very limited at the moment. So these are not finished implementations. So now we are going to see local variables with local names. So this is a way to evaluate things very quickly on the stack. So we are going to do a quick for loop, 1, 10, and we do a for loop. I'm going to use a variable named I, for instance. That's very unique. And I'm going to show I square I squared and add it to what I have on the stack. Let me store that as a program. Let me call that PQR again. And so now if I put X on the stack and evaluate PQR, you see that it added to X the sum of the squares. So you already have some pretty nice constraints. This works with start next, for next, until, while, if is still missing. I've not implemented if yet. Now, what is very interesting with local variables like this is that they are very efficient. You can also use that to create programs with I need to be in alpha mode, with variables like this. So let me store X, Y, oops. So I do a program with 3 local variables, and I'm going to do, let's say, for instance, X times X plus Y times Y, or plus, no. Let's call that, for instance, and put that in my PQR program. And let me test that with a variable called A. Oh, I need 3, sorry. A, B, and C. So now I'm going to evaluate that. And you see that it evaluated my program. So this notation with local variables there, the benefit is that it's very, very fast compared to global variables. So this is recommended way to write programs compared to store and recall, for instance. Next interesting feature, complex numbers. We saw that very quickly earlier. So let me add 2 complex numbers. Or let me try to find the square root of -1. So 1i0, oops, 1i0, so that's +1, -1, and square root, and I've got 0 plus 1i. I can transfer to complex to real numbers, or the opposite. But I can also have numbers in polar representation. So let me have, for instance, a modulus of 10 and an angle of 90 degrees. I think we're in degrees right now. So if I shift to radians, this is going to be shown as radians like this, or grad, or as a fraction of pi. So you have these options for displaying angles like this. Internally, this is represented as a fraction of pi. So this means that the half of pi that we have is exact, which is important when evaluating complex numbers like this. And so if I add this, I get this result, for instance. So complex arithmetic, I think, is fairly complete. You have also transcendental functions on these functions. So why would that fail? Interesting. I need to investigate why this fails. I think this should work. So maybe it's out of range for some reason. So I'll check. I'll replay the video and see why there's a failure there. The tools menu on complex numbers, of course, brings me the complex menu here. I can isolate the real or imaginary parts. If I want to have the norm of this number, or if I want to have if I want to have the conjugate of this number. That seems wrong. I need to check also about this one. I can transfer between polar and rectangular. Another bug. So you see, I explore things and I find various bugs for things that I did not notice. There's one more thing that is interesting about complex numbers, is that you can create them with symbolic values. A plus IB, for instance, times C plus ID. Oops. So if I multiply these numbers, so you see that I can manipulate equations that contain complex numbers for their real imaginary part or for the polar and rectangular form as well. We have, with double shift program, we have lists. So this is the usual list object. I can add objects to a list, or I can multiply a list by a number. Same thing with text, double shift text. I can add text, or I can multiply it by a number in order to repeat it. Another new feature is all matrix and vector operations. So let me do that with a vector containing 3 values, like this. And I can multiply it by 3, add it to the other vector, and I see the result here. For matrices, you simply enter a vector of vectors. And let me do that like this. So there is no matrix editor yet. This will come at some point. So this matrix here is not invertible. If I use the tools menu, I get the matrix menu. I can compute its determinant, it's 0. Let me change it by adding, for instance, a 1 here, and now I compute the determinant. It's non-zero, so that value, now I can invert it, and I have the invert, and you see that it's computing with exact values as fractions. I will let you try it in algebraic mode. We can just give a tease here with let me take the square of that, and you see that it squares all the elements there. I can add it to the other one, and it's added all the vectors values. So I can do all the algebraic operations will apply as well on vectors. And on matrices, I can have matrices of algebraic expressions as well. So I think this is, I've covered most of the features that are working today. So you saw that there are still a number of small bugs, but overall this is a good progress compared to release 0.3 that we had just before. I hope you enjoyed that and that you can test that on your on your DM42.